Hello, today we're continuing in our GCSE Physics Revision series looking at power. Last time we looked at work and energy, and the definition of power is simply work or energy divided by time. So it's the work done divided by the time it takes you to do it. So let's say we have our famous block which has a mass m, and we apply a force F to it, and we push it over a distance of 10 meters, and we take 10 seconds to do that, so the time is 10 seconds. What is the power that we have exerted? Well, the first thing we have to do is to work out the work done. Work is force times distance. That's what we learned last time. And the power is then going to be equal to the work divided by the time. So the power is going to be force times distance divided by time. Let's suppose that the force that we apply is 10 newtons. Then the power is going to be equal to the force, which is 10 newtons, times the distance, which of course was 10 meters, divided by the time, which was 10 seconds. And that is going to give you 10. Well, 10 what? And that's rather intriguing because that's exactly what it is. It's 10 watts. We call power watts. The unit of power is watts. What you could have said is that power is work divided by time. Work is joules and time is seconds. So you could say that power was joule per second. Joules per second. And that would be perfectly fine. But rather than call it joules per second, we use the term watt after a scientist, James Watt, who did a lot of work associated with power. And that's really all there is to say about power. So let's now do some examples that you might be given in an exam setting. Here's the first one, a race. Here you are on your marks, ready to run the race, and at the finishing line, as you run across the line, you are travelling at 10 meters per second. And it takes you 10 seconds, T is 10 seconds, to get from the start to the finish. And your mass, I can tell you, is 50 kilograms. And the question we are asked is, what is the power that you have to employ to run that race? Well, we start by working out the kinetic energy. The kinetic energy that you gain, remember when you start, the kinetic energy is zero because you're not moving. Kinetic energy is a half mv squared, so if your velocity is zero, your kinetic energy is zero. But at the end, you will be travelling at 10 meters a second, which means your kinetic energy will be half times 50 times v squared, which is 100, because v is 10, so v squared is 100, which means that your kinetic energy at the end will be 2,500 joules. Half of 50 is 25, 25 times 100 is 2,500 joules. So that is the energy, in a sense, that your body has had to create to get from a standing start to a position where you're running at 10 meters per second. The power is the energy divided by the time, which is 2,500 divided by the time it took, and you'll remember that was 10 seconds, and so that's going to equal 250 watts. So here you have your 10-second race required you to deploy 250 watts of power. Here's another example. This time you're going to climb the stairs until you are 10 meters above ground level. So you start off at ground level. Again, you're going to have a mass of 50 kilograms, and we're going to get you all the way up to the top of the stairs. And what I want to know is, what power do you need to do that? G, once again, will be 10 meters per second squared, just to keep things simple. So what we are asking first is, what is the gain in potential energy as you climb the stairs? There's going to be no kinetic energy because you're essentially stationary when you start and you're stationary when you stop. So there's no kinetic energy involved, but you have gained potential energy by climbing up through 10 meters. And remember, it's the vertical height that matters, not the jiggly-jaggly bits of getting there. So potential energy is going to be mgh, and that is going to be equal, my mass is 50 kilograms, G, I've been told, is 10, and H is 10. And that's going to equal 5,000 joules. So my potential energy when I reach the top of the stairs is 5,000 joules. What is power? Power is energy divided by time, or work divided by time, and that's going to be 5,000 joules divided by time. And I think I told you, if I didn't, I should have said it takes 10 seconds to climb the stairs. So T is 10 seconds. And so now we've got energy divided by time. 5,000 divided by 10 is 500 watts. So we use 500 watts of power to climb the stairs. Here's a car travelling on the road, and it has reached a terminal velocity, which means essentially that the power of the engine, which is providing a force in this direction, is being exactly matched by the air resistance and frictional forces in the other direction. We covered that in earlier videos. When that happens, there's no net force, so there's no acceleration, and consequently you carry on travelling at a constant speed. And the question then is, what is the power that is used when you do that? Power is equal to work divided by time. Work is force times distance divided by time. But look, distance divided by time is velocity. So this equals force times velocity. So the power is force times velocity when you are travelling at a steady speed. That is when the net force, or the resultant force, is zero. You can say that the power is force times velocity. So let's say that the force of the engine is 2,000 newtons and the velocity is 10 meters per second. What then would be the power of the engine? Well, that would simply be force times velocity, which is 2,000 times 10 is 20,000 watts, or if you like, 20 kilowatts, because 20,000 is 20k. So 20 kilowatts of power required by that engine. A couple more questions. We might be told, for example, that the engine power is 100 kilowatts. And we might be asked how much energy is used in 10 seconds. Well, power is energy over time, so energy is power times time. So in this case, that's going to be the power, which was 100 kilowatts. So remember that you've got to have that K there. It's not 100 watts, it's 100 kilowatts, times the time, which is 10 seconds. So that's going to be 1,000 K. And the energy is measured in joules, so it's 1,000 kilojoules. Here's another one. I want to lift a mass of 100 kilograms. through a height of 2 meters, and I do so in 20 seconds. And G, I can tell you, is 10 meters per second squared. And I want to know what is the power. Well, the first thing you need to do is to work out how much work you have to do. Work is force times distance, and that's going to be 100 times 10, because the force is the weight, which is mass times G. So that's 100 kilograms times 10, which is G, times the distance. You're lifting it through 2, and that comes to 100 times 10 is 1,000 times 2 is 2,000 joules. So that's the work done. What is the power? Power is work over time, or energy over time, and that's going to be 2,000 joules divided by the time it takes, and I think we said that the time was 20 seconds, so that's 2,000 divided by 20, and that's going to be 100 watts. Well, the first thing we have to do is to work out the work done. Work is force times distance. That's what we learned last time. And the power is then going to simply work, or energy, divided by time. So it's the work done divided by the time it takes you to do it. So let's say we have, and we take 10 seconds to do that. So the time is 10 seconds. What is the power that we have exerted? Our famous block, which has a mass m, and we apply a force F to it, and we push it over a distance of 10 meters. Hello, today we're continuing in our GCSE Physics Revision series looking at power. Last time we looked at work and energy, and the definition of power